originating from ancient Greek texts. Cebus produced the first organ and water clocks with moving figures. Hero of Alexandria detailed several automata that were used in theater and for religious purposes. The Greek tradition was revived by Vitruvius, who described several automata and developed the canon of proportions, which is the basis of classical anatomical aesthetics. Arab authors also designed complex mechanical arrangements. Al-Jazari, for instance, illustrated several designs which also anticipated the principle of the modern flush toilet. In approximately 1495, before he began work on the Last Supper, Leonardo designed and possibly built the first humanoid robot in Western civilization. The robot, an outgrowth of his earliest anatomy and kinesiology studies, recorded in the Codex Huygens, was designed according to the Vitruvian canon. This armored robot knight was designed to sit up, wave its arms, and move its head via a flexible neck while opening and closing its anatomically correct jaw. It may have made sounds to the accompaniment of automated drums. On the outside, the robot is dressed in a typical German-Italian suit of armor of the late 15th century. This robot would influence his later anatomical studies, in which he modeled the human limbs with cords to simulate the tendons and muscles. The robot consisted of two independent systems, 3 degree of freedom legs, ankles, knees, and hips, and 4 degree of freedom arms with articulated shoulders, elbows, wrists, and hands. The orientation of the arms indicates it was designed for whole arm grasping, which means that all the joints moved in unison. A mechanical, analog programmable controller within the chest provided power and control for the arms. The legs were powered by an external crank arrangement driving the cable, which was connected to key locations in the ankle, knee, and hip. The recent history of robotics has been dominated not by man as the measure, as Leonardo intended, but by the machine tool. These machines evolved in the 20th century into more versatile general-purpose robots. Early robots were based on components and joints found in their machine tool forebears and were bulky, ponderous, immobile, inflexible, blind, and not at all human. Labor, expensive and unreliable, was regulated and immobilized by chaining the human to a machine or assembly line. Another robot family were teleoperated robots, which are directly controlled by humans. First conceived at Argonne National Laboratory in the 1940s, telerobots were cable-controlled. A true mechanical man requires a different paradigm, similar to that suggested by Leonardo's humanistic philosophy and aesthetics. Leonardo's paradigm has been the guiding inspiration of Mark Rosheim's work on anthrobots. Miniature muscles replace Leonardo's cable system and are mounted with sensors to detect position and forces. New universal joints were invented for Rosheim's anthrobot. A universal joint for the spine, universal joints connected to the clavicle and rotator cuff for the shoulders, gear-driven joints for the elbows, universal joints for the wrists, and ball and socket knuckles and opposable thumbs for the multi-jointed hands. Rosheim's work has culminated in the electric 43-axis robotic surrogate built for NASA Johnson Space Center and intended to service space station Freedom. Thus, Leonardo's vision reaches beyond the confines of our planet to explore